Okay, here we want to evaluate the definite integral. We have x times the square root of a squared minus x squared times dx going from 0 to a. Now, we have to first assume that a is greater than 0. Okay, and then therefore now we want to let u equal what's inside the radical. So u is going to equal a squared minus x squared. Okay, so now we're going to take the derivative of both sides. So when we take the derivative of both sides, what happens? Well, because the value of a is a constant, when we take the derivative of that, it's going to give us 0. So we're going to take the derivative of negative x squared with respect to x. And the derivative of negative x squared is negative 2x dx. Now look back up at the original question. We have x dx, so we need to divide both sides by negative 2. So dividing both sides by negative 2 is going to give us the following. We have negative 1/2 du, which is going to equal x dx. Okay, now let's write the original question. So we're going from 0 to a for our upper and lower bounds. We have the square root of a squared minus x squared times x dx. So now let's go ahead and do our substitution. So we know that we have the square root of u, and we know that x dx is going to equal negative 1/2 du. And so now we need to change our upper and lower bounds according to what we substituted for u. And we know that u is going to equal a squared minus x squared, right? So what does that mean? That means we have to substitute x to be the value of a. So let's go ahead and do that. We have a, which we're going to substitute. So this is going to be a squared minus a squared. And then in the denominator, we know that we have u, which is equal to a squared minus x squared. So that's going to be a squared minus 0 squared. Now, our lower bound is going to be a squared. Our upper bound is going to be 0. We're going to factor out the constant, which is negative 1/2. And then what we're left with is square root of u, which is u to the 1/2 du. Now, with our definitions, okay, we can determine that if we're assuming that a is greater than 0, that means that this lower bound is going to have to be up here. And in order to do that, it's going to change this sign to a positive. So what's going to happen is for this to become a positive 1/2, we are changing our lower limit now to be 0, and our upper limit is going to be a squared to the u to the 1/2 du. So now we're going to go ahead and then take the antiderivative of u to the 1/2. So the antiderivative of u to the 1/2 is u to the 1/2 plus 1, which is 2/2, divided by 1/2 plus 2/2. And then we're evaluating it from 0 to a squared. So now we end up getting 1/2 times u to the 3/2 over 3/2, going from 0 to a squared. And so now if we take the reciprocal of the denominator, we're going to have 1/2 times 2/3 times u to the 3/2, going from 0 to a squared. Okay, so now we're going to factor out the constant. So we have 1/2 times 2/3 times u to the 3/2, going from 0 to a squared. Well, what do we know about the numerator and 2 and the denominator? Well, this is now going to become 1. So now we have 1/3 times u to the 3/2 going from 0 to a squared. Okay, now let's go ahead and then evaluate. So we have 1/3. We're going to plug in a squared for u, so we have a squared to the power of 3/2 minus 0 to the power of 3/2. Now we know this is going to give us 0. So now we're going to have 1/3. We're going to rewrite this as a radical. So the fractional exponent has a 2 in a denominator. So that would be the square root of a squared raised to the power of 3, since that's the numerator. And what do we know about the square root of a squared? Well, the square root of a squared is a. So we have 1/3 a to the 3rd power, and therefore there is our result.